Hi dear students, already in states of matter 19 questions are completed. Next question, at 300 kelvins 1 mole of a gas present in a 10 liters flask exerted a pressure of 2.706 atmospheres. What is its compressibility factor? So first, what is the compressibility factor formula? Compressibility factor is indicated by letter Z. Z is equal to PV by nRT. So if n moles are there, nRT, 1 mole is there, 1 RT, 1 into RT, RT. So what is the pressure value? Here the pressure is 2.706 atmospheres. So 2.706 into what is the volume? Volume is 10 liters. So into 10 by n. How many moles? So present in flask accepted pressure of what is its compressibility factor? So 1 mole of gas. So n value 1, R value already given 0.0821 liter atmospheres, Kelvin inverse, mole inverse. So next into temperature. So what is the temperature? 300 kelvins. So into 300. So 2.706 into 10, 27.06 by, if 300 is 3 into 100, 100 into 0.8, 8.21, 8.21 into 3, that means 24.63. So 27.06 by 24.63 means nearly 1 point something. So the answer is nearly 1.1. So option D. So answer check this once. So answer you check once. So answer 1.1. Next question. At a given temperature, the density of an ideal gas is proportional to density of an ideal gas. So first, what is an ideal gas equation? PV is equal to nRT. So P is equal to nRT by V. So again, P is equal to, N means number of moles. Number of moles formula, weight by gram molecular weight into RT by V. Is equal to weight by volume. Weight by volume means density. So dRT by M. So here D and P directly proportional. That means density is directly proportional to pressure. So the density of an ideal gas is proportional to directly with pressure. So answer P, option B, very easy. At T kelvins and pressure P, the diffusion rate of an ideal gas is 120 milliliters per minute. So what is the time taken for 3000 milliliters of this gas for diffusion at same temperature and pressure? So first, diffusion, the rate of diffusion of gas, R is equal to volume of the gas diffused in the given time. So here he asked what is the time taken. So that means T is equal to V by R. So what is R is 120, volume is 3000 ml. So that is equal to 3000 by 120. So 0 cancel. 300 by 12. That means 2 times 25 times 25. So at same temperature and pressure. So answer is 25. What is this? It is minutes, 25 minutes. If 25 minutes is converted into seconds, 25 into 60. 25 into 60 means 1500. So 1500 seconds. So answer asked in seconds. So answer is 1500. If he asked in minutes, the answer is 25. So he is asked in seconds, that's why the answer is 1500 seconds. Okay, note this. So 23rd question. At 300 kelvins, the following graph is obtained for 1 mole of an ideal gas. If its pressure is 10 atmospheres, then its volume will be. So first you observe the graph, pressure and 1 by V. So it follows which law? Boyle's law. According to Boyle's law, pressure is inversely proportional to volume, or volume is inversely proportional to pressure at a constant temperature and a number of moles of gas. So when pressure is inversely proportional to volume, so P is equal to some constant into 1 by V. If you observe this, if it is y is equal to m into x, y is equal to mx graph. Y is equal to mx means the straight line, it gives the straight line and which is passes through origin, here the slope is m, and that means slope is equal to m, so that is equal to here m value 1.1. So if you observe this, m value is 1.1, that means k is equal to 1.1. So P is equal to K by V. We calculate volume. So volume is equal to K by P. K here 1.1 by pressure. How much the pressure is given? What is the pressure given here? 10 atmospheres. So 1.1 by 10. So 1.1 by 10 means 0.11. So answer A. Very easy. If you know the Boyle's law formula, then it is find out the volume is very easy. If you know the Boyle's law formula, then volume of the gas is finds very easy. So next question, the following data is obtained for this data. For 1 mole of gas, the gas behaves as an ideal gas in the pressure range. That means ideal gas means ideal gas. PV is equal to nRT. That means PV by nRT is equal to 1. PV by nRT means Z. If the compressibility factor Z is equal to 1, then that gas is ideal gas. So PV by nRT, that means for 1 mole PV by RT Z is equal to 1. So which one has pressures values 1 at 1 bar pressure, 2 bar pressure, 3 bar pressure? PV by RT value is 1, 1, 1. So answer is 1 to 3. So answer compressibility factor is equal to 1. Answer 1 to 3. So very easy. If in which the gases acts as ideal behavior, so that is the answer. In which the gas has ideal behavior, that is the answer. So ideal behavior means compressibility factor Z is equal to 1, 1, 1, 1. So answer pressures 1, 2, 3 bar. So A. Okay, note this. See the next question. If two gases, methane and sulfur dioxide, CH4 and SO2, are allowed to enter from the two ends of a 1 kilometer long vacuum tube at the same time, where will the gases meet from the methane end, CH4 end? So if it is vacuum tube, from this side SO2, from this side CH4, gases come close to each other. The distance between the two ends is 1 kilometer. So where they both gases are meet to each other, methane gas diffusion more because molecular weight less, SO2 gas diffusion is less because molecular weight more. Low molecular weight gases are diffused more than the high molecular weight gases. If the distance between where they can meet, that is A. If CH4 meet here, the distance between CH4 and the two gases meet, that distance is A. The remaining distance is 1000 minus A. So understand? Methane gas meet at SO2 gas, that distance is, for example, for suppose it is A, the remaining distance is 1000 minus A. Okay? So first rate of diffusion of CH4 by rate of diffusion of SO2 is equal to, here the given, the gases are allowed to enter from the two ends at the same time. Where will the gases, rate of diffusion of methane by rate of diffusion of SO2 is equal to square root of methane molecular weight of square root of molecular weight of SO2 by molecular weight of CH4, because the rate of diffusion is inversely proportional to molecular weight, square root of its molecular weight, we know. So rate of diffusion of methane means the distance traveled by the methane gas by particular time, the given time. So RCH4 means the distance is A by the distance traveled by the methane, in the distance is A, and in which time the time is both are same, so time is same, so time constant. So here the distance traveled by SO2 is 1000 minus A, that is equal to square root of mass of SO2 64 by mass of methane 16. So A by 1000 minus A is equal to 64. 16 in 64 how many times? 4 times. Root 4 means 2. So A is equal to 2000 minus 2A. 3A is equal to 2000. So A is equal to 2000 by 3. So that means 666.66. So 666.6. So A means at which distance the methane gas meets an SO2, that is A. So A is equal to 666.6. So answer nearly 666.7. Next question, the ratio of rates of diffusion of helium to hydrogen. Very easy. The ratio of rate of diffusion of helium to rate of diffusion of hydrogen. So it is the square root of molecular weight of H2 by molecular weight of helium. So that is equal to square root of molecular weight of H2 means 2 by molecular weight of H means 4, that is equal to root 2 by 2. So that means root 2 is to 1, because 2 means root 2 into root 2, root 2 cancel, root 2 cancel, 1 is to, so 1 is to root 2. So answer 1 is to root 2. So option B. Next question, 20 ml of a gas A and 10 ml of gas B. Two gases, one is 20 ml volume, another one 10 ml volume. Diffuses through a porous membrane separately in 1 minute. Time constant, T constant. If the vapor density of B is X, what is the vapor density of A? Very easy. So R A by RB, that is equal to, here the volume and time is given. So volume by time. Volume of the gas diffused in a particular time is called rate of diffusion. So volume means 20. Time constant. That's why 20 by 10 is equal to square root of vapor densities. Rate of diffusion is inversely proportional to vapor density. So vapor density of vapor density of B by vapor density of A. So that implies 20 by 10 means 2. 2 is equal to vapor density of B is X. So X by vapor density of A. Vapor density of A. So that implies if you squaring on both sides, 4 is equal to X by vapor density of A. So that implies vapor density of A is equal to X by 4. So answer is X by 4. So options are not given. Vapor density of A is equal to X by 4. So answer X by 4. You can note this. This is the next question. The density of a methane is maximum under which conditions? So you know the formula density. D is equal to Pm by RT. So according to density formula, D is equal to Pm by RT. D is equal to Pm by RT means density is directly proportional to pressure and density is inversely proportional to temperature. Density is maximum means density directly proportional to pressure. So high pressure and low temperature. At high pressures and low temperatures, density is maximum. Low temperatures, in 4 conditions, which one has low temperature? Which one has low temperature? Here 0 degrees centigrade, 0 degrees centigrade. These two 73 degrees centigrade are high temperatures. So the answer may be A or D. Because low temperature, density is inversely proportional to temperature, density is directly proportional to pressure. So density, when pressure increases, density increases, temperature decreases, density increases. So answer may be A or D. So next, density is directly proportional to pressure. So in these two, which one has more pressure? So 3 bar compared to 2 bar is more. So answer D. Very easy. If you know the formula, D is equal to Pm by RT. Next question. Which gas among the following is the easiest to liquefy? So in these 4, nitrogen is nonpolar. Nonpolar molecules not easily liquefied. CO2 is also nonpolar. It is also not easily liquefied. So B and D are eliminated. So in the elimination process, B and D are not a correct answers. So remaining A and C, when compared to A and C has hydrogen bonding, but when compared to C, A has a highly polar. So here SO2 is highly polar molecule. Then intermolecular forces of attraction is what? Intermolecular forces of attraction is what? Attraction what? So that's why when compared to ammonia, SO2 easily liquefied. So answer is what? If there is no SO2, the answer is NH3. Okay? Next. In order to increase the volume of gas by 10%, volume of the gas increases by 10%. At a constant temperature, the pressure of the gas should be. What is the relation at constant pressure? At constant temperature, the relation between pressure and volume is constant. Pressure is inversely proportional to volume, or volume is inversely proportional to pressure at constant temperature. So if either V is proportional to 1 by P is proportional to 1 by P. If volume is increased by 10%, then pressure is decreased by 10%. If it is increased by 2%, it is decreased by 2%. If it is decreased by 100%, if it is increased by 100%, how many times volume is increased and the times of pressure also decreased. If it is increased, then pressure is decreased. So volume is, here the volume of the gas 10% decreases means pressure of the gas 10% decreases. So answer decreased by 10%. Very easy. Next, 10 grams of a gas at STP occupies a volume of 2 liters. At what temperature will the volume will be double? So here the relation is volume and temperature. So we know that volume is directly proportional to temperature. With the pressure, an amount of gas remains constant. Pressure constant means at constant pressure, volume is directly proportional to temperature is Charles law. So then V1 by T1 is equal to V2 by T2. So that implies here V1 means volume 2 liters. So 2 by temperature and standard temperature. Standard temperature means 0 degrees centigrade, that is 273 kelvins, equal to temperature at constant temperature. So at what temperature volume will be double? Volume will be double means 2 is converted to 4, so T2. So that implies T2 is equal to 4 into 273 by 2. Then 2 into 4 2 times, 2 into 273 means 5, 4, 6 kelvins. So also 5 or 6 kelvins. So B. What is it? If it is in degree centigrade, 5, 4, 6 Kelvin minus 273, that is equal to 273 degrees centigrade. If the degree centigrade is given, answer is 273 degrees centigrade. But Kelvins are given, so answer 5 or 6 Kelvins. Not this one.